quick recap. Here we go. So, we've been solving systems of linear equations. And we've solved them 3 ways. The first way is by graphing. Now, by graphing, we said that the first thing was to do what? Tell your neighbor, please. You're given a system. What is the first thing you need to do by graphing? Okay. Guys, I said solve for y in slope-intercept form, right? However, now today we're going to think a little bit outside the box because now we know that there's 3 different ways of graphing. Is that correct? So let's see if you catch it. We're going to do one together so that I need you guys to start thinking now outside the box instead of just following those steps. Now that we know that graphing is done other ways, we're going to figure out which is the most appropriate way of graphing once given a system. Number 2, the second way of solving a system is by substitution. And what is the most important thing to do there? Tell your neighbor, please. No. The very first thing you should do. Nope. Solve one equation for one of the variables. Doesn't matter which equation, doesn't matter which variable. And the last method, by elimination. First thing to do is what? Tell your neighbor, please. Nope. Set in standard form. So, the first one, solve for y. The second one, solve one equation for one variable. And the last one in standard form. So, our objective for today, I can solve systems of linear equations by graphing, substitution, and elimination. Let's read together. 1, 2, 3. I can solve systems of linear equations by graphing, substitution, and elimination. Since we already know what systems are, we don't need a Freire model, right? 2 linear equations, right? 2 variables, or the same variables. We already have steps, remember that, for all the stuff that we've been doing. This is for elimination. So now let me go to get started with a practice. On your graph paper that I gave you, it's a special kind of graph paper. If you notice, on one side you only have 1 coordinate plane. Do you guys notice that? On the other side you have 3 coordinate planes. So the flip side, okay, hold on. Those of you that got a graphing paper that looks like Sergio's, show it to everybody. That one's not the correct one. I had placed all the ones on top for you to get from the ones on top. If you got those that have 4 and all that, put those back, put them underneath that stack, please. So, you have 3 on one side and 1 on the other, right? So on one side, should look like this, yes? All right, so get your paper, and you're going to do a trifold. You guys don't know what that is? You guys never you have not done a brochure or a pamphlet? Yeah, fold it in 3. Your paper, fold it in 3. 1, 2, 3.
For the one that only has 1?
It has to look like this. Do a trifold, and it should look something like this. I'm telling you. For some of you, this is the hardest step that you're going to do all day. Okay. So you should have a blank on top, right here, of your graph. So on the top left here, you're going to write example 1, and you're going to copy the following problem. And it says, solve the system by graphing, substitution, and elimination. Next, check your solution and write a statement. And this is our system. X equals negative 3y plus 8, and negative x plus 5y equals 8. Copy that on the top left, which is over here on top of the graphing paper right here. The one with the one graphing paper only. Yes. Copy that, please. Okay. All right, here we go. So, did everybody write the instructions? Solve the system by graphing, substitution, and elimination. Check your solution and write a statement. You're going to write the system. So, I'm going to erase this so I can make some room so I can replicate what you have on yours, okay? All right? All right. So, there's a system, and the first way of solving is by graphing. Is that correct? So what is the first thing we should do? What? Set it in slope-intercept. So I'm going to start with the first equation, and I'm going to write x equals negative 3y plus 8. And let me zoom in. So, to set that in slope-intercept form, what do I need to do, everyone? Solve for y, which means what? Very good. Subtract 8. Subtract 8. We're left with x minus 8 equals negative 3y. Divide by negative 3. Divide by negative 3. What do we have left? Negative 1 over 3x. Why? Because it's a coefficient of 1 right here, right? What else? Negative divided by negative is a positive. How many times does the 3 fit into 8? 2.6 bar. I'm going to leave it as 2.6. But just to remember, when we're graphing, it's a little bit more than the 0.6. Yes? Because we're guesstimating. So let's graph that one. Let me zoom out. So we start at, what is our y-intercept? 2.6, which is about, not halfway, it's a little bit further up, about right there. All right? And what is our slope? 1 down and 3 to the right. So let me ask you. I'm at 2.6. If I take one step down, where do I land? 1.6. Does everybody see that? So okay, here it goes again. I'm at 2.6. I need to take one step down and 3 to the right. So from 1.6, I go down to, 2.6, I go down to 1.6 and 3 to the right. 1, 2, 3. About right there. And let's graph our line. Well, in this case, since we're using decimals and that one's like 2.6 bar, we try and be as precise as we can. You know what I'm saying?
Yes, I got you.
All right. Everybody there? All right, so pens down, eyes up here. Now, according to the steps I gave you, I said solve for y. Is that correct? However, let me challenge your noodle. Here he goes. I don't want you to solve for y on this one. Think about it. Don't say it out loud. What can I do to graph that one without solving for y? Oh, my goodness.
Think about it.
Talk it over with your neighbor. What can we do to this equation to graph it? So the first one, we solve for y so it can be in slope-intercept form. Therefore, another way of graphing this one would be which way? Volunteer. Francisco. Okay, if we solve for x, we're going to end up with an equation that looks like this, right? And do you know what to do from there? Not really. Yes? No, that's another method. How about this? Didn't we just cover the three ways right now at the warm-up? Cover-up method. So what do we have left? Negative x equals 8. Therefore, x equals what?
Negative 8.
Negative 8. So if I cover up the other one, oh, not that one. If I cover up the other variable, what do I have left? 5y equals 8, which means I need to divide by 5 both sides. Therefore, y equals to what? 1.6. Yes.
What do you do when it comes to x equals negative 2x plus 8? To graph it.
What?
We solved it for y.
Yeah, but what if it's not off for y?
Oh, cover-up method. What is x?
8. I could have said negative 8. I mean, I might fall in my...
Okay, be nice, be nice, be nice. All right, here we go. So let's see, let's plot this. I'm going to zoom out. What is my y-intercept? 1.6, which is about right there. What is my x-intercept? Negative 8, negative 4, negative 5, negative 6, negative 7, negative 8. I'm guesstimating on mine. You have your exact coordinates, right? And then graph your line. I'm using red for this one. Going through those two. So, our possible solution for this system is what, everyone?
0 and 2.2.
2, 2. Who sees that?
Oh, I did it wrong. Oh, I see it.
Yes? Do you get something similar to yours?
Yes.
Maybe you're off just a tiny bit because of the scaling, right?
Yes.
All right. So this is possible solution. Possible solution. I'm just going to write solution for right now. Okay? So that's one way, using graphing. So now, does everyone understand that the reason I gave you the first step to solve both of them for y so that you can use the method of using the y-intercept and the slope? However, when you get to tomorrow's part, hey, what other ways do you know how to graph? The table or the cover-up method, right? Everyone understand? All right, let's go to the middle portion of your paper. Here we go. And we're going to label this substitution. Substitution. And what is my system? Let me zoom in. Thank you. Hold on. Hold on. I'll come back. Let me write the system here. X equals negative 3y plus 8. And the other equation was what? Negative x plus 5y equals 8. Negative x plus 5y equals 8. Copy that, please. Here it goes. Everyone, what is the first step for solving for substitution? Solve one equation for one variable. What do you guys notice? This one's already solved for this. Therefore, on the second equation, we're going to write what? 3y plus 8 in the parentheses. Bring everything else down. The negative plus 5y equals 8.
Why is it negative? Why is it negative? Okay.
So what is my coefficient here?
1.
Negative 1. Distribute. So we get 3y minus 8 plus 5y equals 8. Do you know what to do from there? Yes? So, continue, Jocelyn. What do I do? Okay, so what do I get? Continue. Add 8, and I have and then divide by 8, y equals 2. Okay, what do I do from there? Dylan? Which one do you want to use? Substitute that into one of the equations, and they want to use the first one, so I write x equals negative 3y plus 8. Stop throwing stuff. And instead of y, we're going to substitute in there 2. So this is x equals negative 3 plus 8. Let me move this up a little bit. So, negative 3 times 2, that's negative 6 plus 8 equals x. What is negative 6 plus 8? 2. Therefore, my solution to the system is 2, 2. And what do you guys notice? It has to be the same thing because we solve it using a different method. So, we got this one and we got this one. So let me ask you a question. Hold on. Let me ask you a question. Since we found the solution to be the same on the second method, do we have to check at this point? Talk it over with your neighbor. Do we have to check?
It's one of the steps.
Okay. Let's see. Elaborate for us, please. Chris B. Do we have to check? No? Why? So you're saying no because since the answer here or the solution is 2, 2 and over here the same, we pretty much are checking already with a different method. Is that correct? Does everybody understand that? All right. Let's move on to the third method. Third partition. And label that elimination. Elimination. Let me zoom in. So write the system again. X equals negative 3y plus 8 and negative x plus 5y equals 8. So, to use the elimination method, what is the first step? Edgar. Help him out, Caitlin. Set in standard form. Who noticed that we already have one in standard form? Yes, so that we only need to set this one in standard form. So what do I do, everyone? Add 3y, add 3y. We're left with x plus 3y equals 8. Now we can eliminate. So, the x eliminate, and we're left with what? Very good. 8y equals 6t. And then they're both positives. They're both positives. Okay. Divide by 8. Divide by 8. We'll let it slide today since you're not feeling too good. So, y equals 2. Hands if you got that. Okay. And then from there, the same process as the other one, right? Substitute into one of the two equations. Which one do you want to use? The bottom one? Why? Talk it over with your neighbors. Why do you think it's easier or more convenient to use this one to substitute? Talk it over there.
The x is not a negative. The x is not a negative, and then you have to do this.
All right, Dallas, why do you think this one's more convenient?
Because x is in the negative.
And what does that mean?
That x is in the negative.
Patrick? You don't have to divide by -1, or it's less mistakes at the end, because some of you try to go a little bit faster and maybe skip steps. And what would be a last step to skip? Divide by -1 at the end. Does you see? All right, let's substitute. So we substitute for y. That's going to be a 2. Bring down the x plus 3 equals 8. Therefore, this is x plus 6 equals 8. Minus 6 minus 6. X equals 2. Therefore, my solution is what? 2, 2. Solution. Let's see how that looks. Man, look at how beautiful that is.
This is not work.
I'm telling you. So this is the same as this, is the same as this. If you get something different, you made a mistake. Yes. Which one? When you're graphing it here? Okay. Let's see, because I sensed some confusion. The only time that we set it in slope-intercept form is when we're graphing it, yes? But what did we say? Do we really have to set it in the slope-intercept form? Talk it over with your neighbors, please. I want this clarified. Do we really need to set it in slope-intercept form like I gave you the first step at the beginning? All right. Can you elaborate for us, please, Mia? Do we really need to set it in slope-intercept form? No, because if you use the cover-up method, it doesn't necessarily need to be in slope-intercept form. The only time we change it in slope-intercept form is when we're graphing using the what? The slope and the intercept. Everybody with me? The reason I gave you that format at the beginning of system so that you can get used to that process, but now that we're already past that, now our noodle understands we can graph any other way, right? Dallas.
When you asked me why is it easier?
Not easier. Why is it convenient?
Oh yeah. But why would you have to multiply the x by 1, the negative x?
No. Okay. Let me zoom in. Question is, why was this one convenient? Because if we use this one, negative x plus 5 times 2 equals 8, negative x plus 10 equals 8, minus 10, negative x equals negative 2. Some of you go really fast and you stop right there, and guess what? This is not right. What is the next step? Divide by negative 1, divide by negative 1. That's the possible mistake some of you will make. That's why it's more convenient using all positive, an equation that has all positive numbers. Because it's convenient, not easier. I think all of them are easier, it's just that it's convenient. Now, we're almost done. What is the last thing on the instructions? Write a statement. So, think about your statement. So, let's see, what's your statement, please? Olivia. The solution to the system is 2, because both equations are true, and it's where the two lines intersect. Does everybody agree with that? Kind of, sort of, yeah? The solution to the system. So clear. 10Q.
Oh, we can write that in the pop party?
Yeah. Now, for tomorrow's party, I'm only going to give you a system, and that same paper that you're taking, that one that has one little graph, I'm going to ask you solve it 3 ways.
This is the study guide, bro.
This one. Yeah. Be nice.
Both equations are what? Like true.
True. Yeah. I don't know. Yeah.
On the one on this side, so those two, we do them like that, but are we going to have to do it, especially one of the 3 forms that you can do it?
I'm going to ask you to solve it 3 ways.
But like that one of the 3 that
It's exactly what you did today. That's exactly what we're going to do tomorrow.
But like, can you do the cover-up method in that one?
Oh, the graphing you can do whichever way. Okay. All right. So, we're done with this, right? So, once again, tomorrow, you're going to get the same paper with a little graph here. You're going to fold it into 3. And you're going to have to solve the system by graphing, substitution, and elimination in that order. Why? Because that's in the order that I introduced systems to you, right? We started with graphing, then we went to substitution, and then we went to elimination. Yes? So let me recap on the graphing again. Because if you notice, flip the paper over really quick, the one you just have. Who notices that in the back there's 3 graphs or 3 coordinate planes? Well, guess what that is for? I'm going to give you one equation, and I'm going to ask you to graph it how many different ways? 3 ways. So let's do the warm-up in the back. So copy this one, example number 2 from the warm-up. Get that graph paper in front of you. Right at the top, number 2, 4y minus 20x equals negative 28. Okay, so I'm going to start with the first way I showed you, which is
1.
Graphing.
Slope-intercept.
using the table. That's the first way that we started graphing, didn't we?
Oh yeah, with the total.
So let's solve for y. So I add 20x to each side. 4y equals 20x minus 28 divided by 4. Y equals 5x minus 7. And then from there, we get a table going. The domain is from negative 2 to 2. So let's see. Negative 2 times negative 5, negative 2 times 5, that's what? Negative 10 and negative 7, negative 17. Next value. Negative 1 times 5, that's negative 5. And negative 7, negative 12. 0 times 5, 0, and we're left with negative 7. Do you see the pattern now? So what's happening from here to here? Adding 5, so what is my next value? Negative 2, and the last value? 3, 20. So this is 2, 3, 1, negative 2, and 0, negative 7. Graph our line.
Mr. Can we use any of those that you had, like negative 2, negative 1, 0, 1, 2? Can we use any of those? It would just be parallel, right?
Okay, that's one way. What is the next method that I showed you? Using the cover-up method. So watch. I can actually use the same equation right here. Cover up the x. What do you see? Negative 7, which is right here. Now if I cover up the y, what do you see? 0 equals 5x minus 7. Let's solve for x. Plus 7 plus 7. 7 equals 5x divided by 5. Therefore, this is 1.6 equals x. So I'm going to use that. I already graphed y equals negative 7. Now I'm going to graph x equals 1.6, which is about right here. Everybody see that? And the graph, that's using the cover-up method. There it is. And the last method. Hold on, let's finish off. The last method, what is my y-intercept? Negative 7. What is my slope? 5 up, 1 to the right. 5 up, 1 to the right. So, be nice. So once again, 3 different graphs or 3 different methods. So your home plate for tonight is found on page 301. Okay, I'll wait for everybody to be seated. Page 301, numbers 9 through 11. Now pay attention to this part. Don't pay attention to the instructions. What I need you to do is get those 3 systems. What 3 systems? Number 9, number 10, and number 11, and solve them 3 different ways so you can get practice for tomorrow. Have a good one, guys. Enjoy your home play. See you guys till later. Bye.